Hi pre-calc. Okay, now we're going to do 2.2 polynomial functions of higher degree. When you graph a polynomial function, they are smooth and continuous. It means that if I started on one side, I would not have to take my pencil off the paper to finish it. It's just smooth and continuous. Smooth and continuous means that there are no holes, there are no gaps, and there are no sharp turns. No holes, no gaps, no sharp turns, no vertical asymptotes in the middle. It would be a roller coaster ride that would be not missing any spots, okay? This technique is an approximation technique. It is not an exact thing. Once you go to calculus, you will get all the hills and valleys of the polynomial functions, which we do not do here. Okay, we're just going to approximate what it looks like. All right, there's two skill sets that I'm going to show you before we actually draw this. So the first thing I'm going to show you is something called the leading coefficient test. The leading coefficient test tells you what's happening at the ends of the graph. It's not referring to the middle, okay? It is not referring to the middle. If the degree of the polynomial is like even, if the degree of the polynomial is even, then what happens on the ends is that it either goes up, up, or it goes down, down. The difference is if the leading coefficient is positive, the graph goes up, up. If the leading coefficient is negative, the graph goes down, down. I will give you specific examples on this in a minute, but let me just give you the general concept, okay? If the degree of the polynomial is odd, it's like a 7th degree, a 9th degree, then the ends will go in opposite directions, down, up, or up, down. If the leading coefficient is positive, it will do down, up. If the leading coefficient is negative, it will do up, down. Okay, those are the rules on how to do the leading coefficient test. And I will give you some exact examples now so that you can understand it better. All right, so the first thing you have to do is figure out what is the degree of the polynomial. The degree of the polynomial is the highest x value. So I only have one x value here, but let's say I had more. Okay, I can just add on to this. Okay, let's say I had more x's. Okay, the degree of this polynomial is a 4. It's the highest exponent. So what this rule says is that if you have an even degree, this is even, right? 4 is an even number, that it's either going to go up, up on the ends or down, down. That's what evens do. They go together. They're either going up together or down together. What determines which case it is whether it's positive or negative in the front. So if it's positive in the front, it's going to go up, up. And I'm just going to put like a little disco dancer here so you remember, right? This sort of reminds me of, this is probably past anybody's age, but it just sort of reminds me of John Travolta disco dancing, right? Both his arms are going to be up. That's an even degree with a positive leading coefficient. It doesn't matter what the number is. It matters whether it's positive or negative. Okay, so on the ends of this graph, it will go up, up on this graph. It'll be this case. Okay, we're not talking about what happens in the middle. We're talking about what happens at the ends. All right, next case. This is a degree 6. That's the highest x. That's the highest x value, so it's degree 6. If it's even, which this is, what I just said before, they either go up, up, or down, down. They go together when it's an even degree. So now you have to look at the positive or negative of the leading coefficient to decide which case it is. Since it's negative, it's going to go down, down. If it helps, for some people, if you just think of a parabola, because a parabola is even, if the parabola is positive in the front, you know it's face up. If the parabola is negative in the front, you know it's face down. It's the same concept. If it's positive in the front, it's up, up. If it's negative in the front, it's down, down. Parabola is even, right? The degree of the polynomial is even. Okay, so now let's do the next one. So the degree of this one is a 3. Okay, that's odd. Odd means it's going to go in opposite direction. It's going to either go down, up, or up, down. That's what odd means. It's going to go on the end, it's going to go in opposite directions. How you determine which of the two cases it's going to be is you look at whether the leading coefficient is positive or negative. Since it's positive, it's going to be this case. It's going to be down, up. All right, there's my disco dancer. Oh, yeah. All right, next one, degree. I could write degree 3 here. Degree 3. Okay. Degree of this guy is a 7. That's odd. Odds again go in opposite directions. It's going to go either up, or up, down. How you determine which of the two it is you look at whether the leading coefficient is positive or negative. If it's negative, it's going to go up, down. Let's attach your arm there. Okay. All right, so if it's helpful for you, you can think of a cube function. If normally a cube function would be up, down, like this. So if it's positive, it does the same thing. It does the same thing, this down, up dance. If you put a negative in front of a cube, it goes up to down. Okay, so if that helps you, like for me, these tend to help me. I know what these like simpler functions look like on the end, so then I just extrapolate it onto a fancier function. Okay, all right, so that is the leading coefficient test. Let me see, we're at 6 minutes. Okay, maybe do a little bit more here. All right, skill number 2 is what we would call even and odd x-intercepts. An x-intercept, again, is when you set the function equal to 0. In the factored form, if you look at whether the exponent is even or odd, if the exponent is even, it means that when it touches the x-axis, it's going to bounce. It's either going to bounce upward or it's going to bounce back downward, but it will not cross it, okay? It will not cross it if in the factored form the exponent is even. If this sounds really abstract, which it probably does, it'll make more sense when I put it all together, okay? Just try to get the rule down and then you can always come back and look at it again once we start solving problems. All right, if in the factored form the exponent is odd, what happens when you come to the x-intercept is it will go through it. Locally, it looks linear or cubic, okay? It can go through it from bottom to top or from top to bottom. But the idea is if the exponent is odd on the factored form, it's going to tell you that what the x-intercept is doing locally, whether it's bouncing or whether it's going through the x-axis. Okay, so in the next video, we will start to graph these. Again, these are just approximations, and I'll use these 2 skills that we just learned. Catch you soon. Bye.